Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to YouTube channel Chandan Physics. In this video, we are going to discuss Wien's distribution law and its proof. Let's begin. In the previous video lecture, we have already discussed about Wien's displacement law. Here, we explain what is Wien's distribution law. This law shows that the energy is not uniformly distributed in the spectrum of thermal radiation of a black body. As we discussed, if we plot a graph in between wavelength lambda along x axis and energy of that radiation corresponding to a particular wavelength E lambda along y direction for a black body at a particular temperature, the curve is looking like this. At a particular temperature, as we increase the temperature, then the maximum wavelength corresponding to that of energy gradually decreased. Here we consider a small wavelength d lambda corresponding to that of wavelength, that d lambda means the wavelength range from lambda to d lambda. What be the energy of that spectral radiation? This can be calculated by using Wien's distribution law. So, how energy is not uniformly distributed in that of spectrum of thermal radiation of a black body is calculated mathematically. The amount of thermal energy contained in that of spectral region from wavelength lambda to lambda plus d lambda, and that amount of thermal energy is called E lambda d lambda corresponding to that of wavelength lambda to lambda plus d lambda. The energy is E lambda that emitted by a black body at particular temperature T is given by that of expression E lambda d lambda is equal to A divided by lambda to the power fifth f of lambda t d lambda. E lambda d lambda is called the spectral energy density between lambda to lambda plus d lambda. What be the spectral energy density within this wavelength is considered as E lambda d lambda. Next, A is a constant, f of lambda t also the function of product lambda t. Next, that expression which is called Wien's distribution law also can be written as, in terms of temperature, E lambda d lambda is equal to A t to the power fifth f of lambda t d lambda. What exactly that Wien's distribution law emphasize? What amount of thermal energy contained in a particular spectral region is easily calculated by using Wien's distribution law, that be the formula. Now, we can prove it. Proof of that law named as Wien's distribution law. How to prove? As we consider in case of Wien's displacement law, to prove lambda into T is equal to constant wavelength corresponding to that of temperature, the product of wavelength and temperature is equal to constant. Here we consider a spherical container, having radius r, which one is perfectly, the walls are perfectly elastic and these walls are also expandable. Inside that of spherical container there are photons. By that of photons we obtain diffused radiation, and these diffused radiations creates pressure on that of wall. If that photon are incident on that of wall, then it will be reflected back. As we say, at the same time that wall is expanded, therefore it will be expanded to this and then reflected back. That distance is dr. That radiation have a wavelength lambda and the wavelength change as d lambda. Then we use Doppler's effect and finally prove. Again, that container is an isolated system. Therefore, the total heat inside that of container is constant, means it's an adiabatic process, and change in heat is equal to 0. As we know that the emissive power corresponding to that of wavelength lambda, that is E lambda, which is directly proportional to the energy density. Mathematically we can say emissive power E lambda. Look at that figure. In that of wavelength range, lambda to lambda plus d lambda, that emissive power will be E lambda d lambda, which is directly proportional to that of energy density. Energy density small u corresponding to that of wavelength, that is u lambda d lambda with the energy density. U is the energy density, energy per unit volume. In that of sector, if we choose a unit volume, then energy in that of unit volume will be u lambda, corresponding to that of wavelength it will be u lambda d lambda. U lambda d lambda, u lambda is the energy density corresponding to that of wavelength lambda. Here the volume of that of a sphere V is the volume of that spherical body and capital U with the total radiant energy within this, let this one is equation number 1. The total internal energy of radiation in that spherical body is equal to U, which is equal to U with the total energy is equal to that energy density into volume. Energy density corresponding to that of particular wavelength lambda is small u lambda d lambda, then it is multiplied with that of volume V, that with the total energy in that of spherical body. As we say, this is an isolated system, since that system is isolated, so it executes adiabatic process that is the change in heat dq is equal to 0. Q, the heat in that of system, for adiabatic one the change in heat is 0. Then using first law of thermodynamics, dq is equal to du plus pdv, which is equal to 0, that is from first law of thermodynamics. The amount of heat supplemented to that of system used in change in internal energy and some work done. Here total energy U is equal to u lambda d lambda V. So derivative of u lambda d lambda V plus here the pressure, as we say these are the diffused radiations. So what will be the pressure of that of diffused radiation, which one is 1/3 of energy density u lambda d lambda, 1/3 of energy density dV is equal to 0. As we say diffused radiation pressure is equal to 1/3 into energy density. Here diffused pressure P is equal to 1/3 of energy density u lambda d lambda, energy density corresponding to that of wavelength lambda. Okay. Now we have to differentiate it 3 terms. So differentiation of first term, another 2 are constant. Next differentiation of second term, another 2 are constant, like this. So first differentiation of first term as d u lambda, then another 2 terms are constant d lambda v. Again differentiation of second term, these 2 terms are constant, so u lambda. Next differentiation of second term, it will be d square lambda constant term v plus then differentiation of that term, another two are constant, u lambda d lambda, then differentiation volume dv plus 1/3 uv d lambda dv is equal to 0, or here d lambda term dv term that is u lambda d lambda, here u lambda d lambda, therefore it is written as du lambda d lambda v plus u lambda d square lambda v plus 1/3 1, which one is 4/3 u lambda d lambda dv is equal to 0. In that of entire term we divide u lambda d lambda v, dividing u lambda d lambda v on both sides. Du lambda d lambda v divided by what, u lambda d lambda v plus u lambda d square lambda v divided by u lambda d lambda v plus 4/3 u lambda d lambda dv divided by u lambda d lambda v is equal to 0. Then du lambda divided by u lambda, another two are cancelled out, plus u lambda v cancelled out, that is d square lambda divided by d lambda plus 4/3 dv by v is equal to 0. That equation number 2. Here the term d square lambda by d lambda, which is equal to, that is the differentiation of d lambda with respect to d lambda, as it says d lambda changes in the same way as lambda changes. Since d lambda changes in the same way as lambda change, therefore d square lambda by d lambda nearly equal to d lambda by lambda. Okay, that equation number A. Again from that of spherical body, again volume of that sphere v is equal to 4/3 pi r cube, taking logarithm log of v is equal to log 4/3 log pi plus log r cube. Taking logarithm, then differentiating both sides, we get that is 1/v dv plus log of that term constant 0, log of pi 0 plus log r cube, first 3 with a constant, log r 1/r dr. Okay, that is written as dv by v is equal to 3 dr by r. Now one thing we can supplement from Doppler's effect, as we saw in that previous video as deriving Wien's displacement law, as d lambda by lambda is equal to dr by r. As that wall is expandable, at that of same time that wall is expanded to this, and that radiant wave incident and reflected. So change in wavelength to that of original wavelength ratio is equal to change in distance to that of original distance. D lambda by lambda is equal to dr by r. In place of dr by r, we can substitute d lambda by lambda. Therefore dv by v is equal to 3 times, in place of dr by r, that is d lambda by lambda, which one is equation number B. Now that equation number 2 can be rewritten as, therefore equation 2 written as d u lambda plus next d square lambda by d lambda, as you substitute, that is d lambda by lambda plus 4/3, here dv by v as 3 d lambda by lambda is equal to 0. Okay, now we can solve it. It is d u lambda by u lambda plus d lambda by lambda, 3 cancelled out, plus 4 d lambda by lambda is equal to 0. So d u lambda by u lambda plus d lambda by lambda, 4 d lambda by lambda, that is 5 d lambda by lambda is equal to 0. Taking logarithm on both sides, taking logarithm on both sides, that is integrating both sides, taking integration, that is d u lambda by u lambda integration plus 5 d lambda by lambda integration is equal to 0, or its integration results as constant. Zero, or here log u lambda plus 5 times log lambda is equal to constant, or log u lambda plus log lambda to the power fifth is equal to constant, log a plus log b, log a b, log u lambda into lambda to the power fifth is equal to constant. Simply u lambda lambda to the power fifth is equal to e to the power constant, that is again a constant. Okay. From that equation, the value of u lambda can be calculated. U lambda is equal to constant divided by lambda to the power fifth. Let I take it as equation number 3. Now, equation 1 becomes, as equation number 1 we write e lambda d lambda is equal to u lambda d lambda. Therefore, that expression e lambda d lambda is equal to u lambda d lambda, or e lambda d lambda is equal to, in place of u lambda, that is constant divided by lambda to the power fifth d lambda. As we say, u lambda lambda to the power fifth is equal to constant. Therefore, u lambda is equal to constant divided by lambda to the power fifth. Okay. Or e lambda d lambda, that is constant. From Wien's displacement law, the product of wavelength and temperature lambda t is equal to constant. So, instead of that constant, we can use the product of lambda t, that is a function of lambda t. So, here we can write a function of lambda t divided by lambda to the power fifth d lambda. That is e lambda d lambda is equal to the constant a lambda to the power fifth f of lambda t d lambda. That is proved. That is proved. Again, another form how it is related to that of temperature, a to the power fifth f of lambda t d lambda. That first one is proved. Next, second one. To prove that of second one, we have to take in u lambda t as constant. Again, we know lambda t is equal to constant. Therefore, lambda t to the power fifth is equal to constant, means lambda to the power fifth t to the power fifth is equal to constant. In place of lambda to the power fifth we write constant divided by t to the power fifth. This is putted in that of equation number 3. Therefore equation 3 becomes u lambda to the power fifth is equal to constant. In place of lambda to the power fifth we substitute, that is constant divided by t to the power fifth is equal to constant. Therefore u lambda is equal to constant divided by constant, also a constant, means that t is multiplied, so t to the power 5 into constant. Now therefore equation 1 becomes equation 1 e lambda d lambda is equal to u lambda d lambda. In case of u lambda we substitute t to the power fifth constant, so e lambda d lambda is equal to t to the power fifth into constant d lambda. Here in case of constant, that is the function of lambda t into a constant multiplied as a. Therefore e lambda d lambda is equal to a constant a, then function of lambda t into t to the power fifth d lambda. So e lambda d lambda is equal to a is a constant, that constant is multiplied f of lambda t, function of lambda t d lambda. This one is proved, that one is proved. The two forms of Wien's distribution law is proved. From that of expression we can say that E is directly proportional to that of temperature. Here we can say E is inversely proportional to that of wavelength. Of the energy distribution of blackbody radiations. So here with the help of this video lecture we understand what is Wien's distribution law of blackbody radiation, mathematical form, energy radiation, the thermal energy emitted in that of spectral range lambda to lambda plus d lambda. Its proof. First form, how it is related to that of wavelength. Next, second form, how it is related to that of temperature. So with this useful and informative notes, let me wind up the session. Thank you.